From Cape Canaveral Air Force Station in Florida, you are watching live coverage of the launch of the SpaceX Falcon 9 rocket and Dragon capsule. This is Falcon launch control at T-minus 1 hour, 10 minutes, and counting. SpaceX-3 is the third of at least 12 commercial resupply missions to the International Space Station for SpaceX. Under the Commercial Resupply Services contract, SpaceX is restoring America's capability to deliver and return significant amounts of cargo, including science experiments, to the space station. It's a capability that we have not had available since the Space Shuttle retired. Dragon is going to be carrying about 5,000 pounds of supplies and experiments to the station and returning about 3,500 pounds. Prior to this flight, SpaceX successfully completed 2 demonstration missions using Falcon 9 and Dragon under NASA's Commercial Orbital Transportation Services Program, or COTS, and also 2 Commercial Resupply Services flights. Everything is set here at Space Launch Complex 40 for today's launch of the SpaceX Falcon 9 rocket to send Dragon to the space station. Liftoff is now targeted for an instantaneous launch window at 3:25 and 22 seconds p.m. Eastern Daylight Time. At the time of launch, the space station will be flying at an altitude of 260 miles over southeast Turkey. And with the launch today, the grapple of Dragon by Expedition 39 Commander Koichi Wakata and flight engineer Rick Mastracchio using the Canadarm2 robotic arm will occur on Sunday at 7:14 a.m., followed by berthing to the Earth-facing port of the Harmony module. During last Monday's launch attempt, pre-flight checks detected that a helium valve in the Falcon 9 stage separation pneumatic system was not holding the correct pressure, which removed redundancy from the system and meant that the stage separation pistons would be reliant on a backup check valve. There was no issue with the backup valve. SpaceX has replaced the faulty valve, inspected the entire system, everything was buttoned up, and the system is operating fine today. Everything technically is go. The weather forecast is still officially calling for a 40% chance of favorable weather, with a chance of showers and thunderstorms that could result in violating the thick cloud, lightning, and flight-through precipitation rules. The temperature at liftoff is forecast to be 75 degrees, winds 15 knots from the southeast. Earlier today, a large cluster of storms located over the eastern Gulf of Mexico pulled through a warm front and a low that brought a lot of showers and thunderstorms to the Kennedy Space Center area. And later today, strong jet stream energy is expected to spread out over the entire central Florida area, which will cause our air mass to become unstable again and regenerate those showers and thunderstorms. They're predicting perhaps around 6 p.m. to midnight, localized areas of strong wind gusts, torrential rains, cloud-to-ground lightning, and possible hail. But as you see on the radar, everything is clear now. The systems have moved out of the way, and the launch weather officer is optimistic that nothing is going to redevelop during the launch window between now and T0 at 3:25 p.m. Several months ago, both Falcon 9 rocket stages and the Dragon capsule were transported to SpaceX's development facility in McGregor, Texas for testing, and then they were trucked individually to SpaceX's hangar at Space Launch Complex 40 here at Cape Canaveral Air Force Station in Florida. There, the stages were integrated, and Dragon was loaded with its cargo. The final major pre-flight test was a static fire when Falcon 9's 9 first-stage engines were ignited for 2 seconds, with the vehicle held securely to the pad, and that test was successfully performed on March 8th. NASA and SpaceX personnel collaborated on the design and rendezvous profile, including both the timing and the path of Dragon's approach to the space station, and worked together to identify a process and pack the NASA and international partner cargo that is to be delivered to and from the space station. A formal stage operations readiness review was conducted, which involved representatives from NASA and all 5 of the space station's international partner agencies: NASA, the Canadian Space Agency, the European Space Agency, the Japan Aerospace Exploration Agency, and the Russian Federal Space Agency, or Roscosmos. This ensured that the launch vehicle, spacecraft, cargo, the space station, and launch and operations teams were ready for the mission. Last night, Falcon 9 with Dragon mated was again transported to the launch pad. It was elevated to the vertical position for launch at 8 a.m. this morning. Falcon 9 and Dragon have been powered up. The systems have been activated. The computers have been turned on. At 11:47 a.m. today, the fueling process began with RP-1 propellant, which is a rocket-grade kerosene, and liquid oxygen fed into both stages of the Falcon 9 rocket. The plume that you see coming off of the two stages is gaseous oxygen being vented from the tanks, which is why the liquid oxygen is topped off throughout the countdown. SpaceX will be delivering the 5,000 pounds of science and research, crew supplies, vehicle hardware, and spacewalk tools to the International Space Station, and this will support more than 150 scientific investigations that are occurring between Expedition 39 and 40. The scientific payloads on Dragon include investigations focusing on efficient ways to grow plants in space, demonstrating laser optics to communicate with Earth, human immune system function in microgravity, and Earth observation. Aboard Dragon are a set of high-tech legs for Robonaut 2, which can provide the humanoid robot torso already orbiting aboard the orbiting laboratory with the mobility it needs to help with regular and repetitive tasks inside the space station. Dragon also will deliver the second set of investigations sponsored by the Center for the Advancement of Science in Space, or CASIS, which manages the portion of the space station designated a U.S. national laboratory. CASIS investigations on Dragon are part of the organization's initial suite of supported payloads linked to Advancing Research Knowledge 1, which stands for ARC-1. The investigations include research on protein crystal growth, which may lead to drug development through protein mapping and plant biology. When Dragon splashes down in the Pacific Ocean west of Baja California, it will bring back with it 3,500 pounds of science, hardware, crew supplies, and spacewalk tools from the space station. The SpaceX Falcon rocket also will jettison 5 small satellites known as CubeSats during ascent to provide an array of technology demonstrations. These small satellites are part of NASA's educational launch of Nanosatellite, or ELANA mission, and involved more than 120 students in the design, development, and construction. So a lot is planned for this SpaceX 3 mission once the Falcon 9 launches from the pad at 3:25 p.m. We're standing by shortly to hear a weather briefing from U.S. Air Force 45th Weather Squadron Officer Mike McAleenan, where he will be updating the SpaceX launch director and the entire team with the current weather conditions and the forecast for the time of liftoff. This is Falcon Launch Control. This is Falcon Launch Control at T-minus 1 hour and counting, standing by for a weather briefing from 45th Air Force Weather Squadron Officer Mike McAleenan.
This is the LWO with the L-1 hour range weather briefing. For those of you with video capability, you can see a large cloud mass in the eastern part of the Gulf of Mexico, approaching the west coast of Florida. It is associated with stalled frontal boundary that is moving through the center part of the Gulf with a large area of unsettled weather and cloud cover. Moving into a closer picture, you can see that most of this cloud cover in the southern southeastern third of the peninsula is mostly thin and is not a violation of any launch criteria. Looking at the radar, you can see we've had several bouts of rain showers and thunderstorms move through this morning, but right now everything upstream has dissipated, and it's looking quite favorable for the remainder of the count. Looking at the launch conditions at the complex, weather at Complex 40, temperature is right around 76 degrees with that strong south-southeasterly flow on shore. Don't expect it to increase too much, and especially with the cloud cover as well, we haven't seen much of a change from overnight temperatures. The wind speeds have been quite fluctuating from 10 to 15 knots sustained to peaks around 20 to 22. Earlier when we had some more unsettled weather this morning, we had peaks almost to 30, but it looks like it's settled down to 15 peak to 20 on the knots, which is about 20 peak 25 miles an hour. The direction has shifted since we had a warm frontal boundary move through. We went from easterly to southeasterly and expected to remain southeasterly through the count, eventually becoming southerly and southwesterly later after the window. We did also have a solar event. We had an M-class flare that did elevate the protons a bit. The 10 MeV elevated just past 10 to the 1, but the launch commit criteria 50 MeV protons, the blue line here, did not accelerate up to that level, and as you can see now, it started to trail back off. So we are still a moderate risk of any kind of solar activity with the elevated protons at this time, but so far we've seen no other events to increase that proton activity. And for the first time in a while, we are go on all launch commit criteria for range safety, and we are seeing in the recovery area wave heights a bit above what they'd like, but ships are out there, and we're able to track, and hopefully we'll see what we can do with the first stage landing over the water area. A forecast for the remainder is scattered skies in the low levels becoming overcast in the upper levels. We do have some showers off to the west, but those look like they've diminished, so we'll probably change this to 7 miles with no restrictions. Winds have become out of the 160 degrees or so out of the southeast, with sustained winds around 20 miles an hour and peaks to 25. Again, we're moderate on solar activity, and we've dropped the probability of any violation through the remainder of the window to 40%. Should we delay to tomorrow, that low pressure area moving into the western part of the peninsula moves off towards the north and east into Georgia coast in the Atlantic over the Gulf Stream and begins to deepen. So there is a threat of some wraparound clouds associated with that. So we're keeping the clouds in the forecast. Winds will switch around just north of west, and still fairly strong. Temperatures will drop behind the cold front, which is due through in the early morning hours between maybe 7 and 9 a.m. So a 30% chance of violation for tomorrow. Again, and that's if there's a chance of those wraparound clouds, or if the winds are a bit stronger with the deepening low, then we may see a liftoff wind violation. If we were to go into Tuesday's attempt, the low continues to move and off towards the north and east, and our weather continues to improve. So just scattered skies, winds come around northeasterly. But just in case that low is not quite quick enough to move, we're maintaining a 20% chance of violation. And again, with the thick and potential cumulus cloud rule with onshore flow. So that's all I have, unless there's any questions.
At T-minus 55 minutes and counting, everything is go for weather, as you just heard. There are currently no constraints, and the updated forecast is calling for a 60% chance of favorable weather with just a chance for anvil clouds and cumulus clouds. Temperature at the time of liftoff forecast to be 76 degrees, and winds from the southeast at 20 knots peaking to 25 knots. So weather is go, and in Houston, the home of the Johnson Space Center and the International Space Station Mission Control Center, the flight director just polled the room and has given a go for the launch of Falcon and Dragon. Everything continues toward a liftoff time at 3:25 and 22 seconds p.m. Eastern Daylight Time. This is Falcon Launch Control. This is Falcon Launch Control. Today's launch of SpaceX 3 is a very important step forward in NASA's stepping stone approach to future space exploration destinations. This and the other resupply missions are sustaining the International Space Station and the crews throughout the operating life of the station, which has now been extended to 2024. This extension is enabling NASA to continue to be a catalyst for the growth of the American commercial space industry. Both SpaceX and Orbital Sciences Corporation are making regular cargo runs to the space station, and later this year, NASA will move beyond commercial cargo and award contracts to American companies to send astronauts to the station from American soil and end our sole reliance on Russia. NASA's Commercial Crew Program is facilitating the U.S. commercial aerospace industry's development of safe, reliable, and cost-effective human space transportation to and from low Earth orbit and the space station. And NASA is relying on its decades of human spaceflight experience to certify these crewed vehicles, and the partnerships with industry are forging evolving global space economies and continuing the U.S. leadership in human space exploration. So with the space station operating until at least 2024, it has become the springboard for exploration of deep space and Mars, and the key to NASA's dual-path approach, providing a destination for American commercial space vehicles to fly U.S. astronauts from American soil, and a platform to perform research and develop technologies that will enable the Space Launch System rocket and Orion spacecraft to carry us farther into space than ever before. Because the space station is there, there's an expanded market for private space companies, more groundbreaking research and science discovery in microgravity, and opportunities to live, work, and learn in space over longer periods of time. The astronauts aboard the station are helping us learn how to safely execute extended missions deeper into space, and later this year, we'll see Exploration Flight Test 1 of Orion on a United Launch Alliance Delta IV Heavy rocket, an exciting mission yet to come this year. And meanwhile, NASA is pressing ahead with the development of the Space Launch System with Orion for an uncrewed mission of the two craft together in fiscal year 2018. In addition to continuing station research, strengthening partnerships with commercial and international partners, and building the next generation heavy lift rocket and crew capsule that will take our astronauts farther into space, NASA's stepping stone approach includes a plan to robotically capture a small near-Earth asteroid and redirect it safely to a stable orbit in the Earth-Moon system, where astronauts can visit and explore it. This asteroid redirect mission will help us develop the technologies, including solar electric propulsion, that we'll need for future deep space missions to Mars. Under the Asteroid Initiative, we will enhance detection and characterization of near-Earth objects and improve the understanding of asteroid threats to planet Earth. NASA has produced a video that explains all the exciting work that is underway today and where it will be taking us tomorrow.
a big watch. We're having fun. Let's go! We're going to the sun. Yeah, look at the rocket ship.
At NASA, we're reaching for new heights so that we remain the world's leader in space. We're pioneers, and we always have been, and we're building on that pioneering spirit in science and technology so that we make the world a better place, and we create jobs right here on Earth.
Everything we do is unique.
And when you explore space, you learn not only about what's out there, but what's down here, and why it's the way it is.
We have the best engineers and scientists in the world, and today, right now, they're developing game-changing technologies for our next great achievements in space.
We're building something that can go lunar, we can build something to go to an asteroid, we can go to Mars with this. This is the next step that we've been looking for since the Apollo era.
With Orion and our heavy-lift space launch system, we're going to send humans into space farther than they've ever gone before. This year's Orion test flight will be the most aggressive for a human spacecraft in more than 40 years.
Apollo happened before I was born, so this for our generation will be the exploration missions that we get to see in our lifetime.
As the NASA administrator, I feel like a new father because as a result of NASA's efforts, we now have an American capability to get our cargo to the International Space Station through Orbital Sciences and SpaceX. And in just a few years, we're expecting that we'll have that same ability to get our own astronauts to space from American soil, where we ought to be launching.
Yeah, it feels good in there.
That's going to be an amazing day when that finally happens, that a private company gets to go do this. It's just going to be amazing.
We are going to have our own safe, reliable, American-made vehicle.
Well, the crews right now on the International Space Station are using this wonderful outpost to help us get farther and farther into space, to asteroids, to Mars eventually. I think the science on station is making incredible breakthroughs that are going to help us make life better for people right here on Earth.
We and our other international partner crewmates are working off the planet for the planet.
NASA, along with our international partners, conducts scientific research every day here on the station as we use this orbiting laboratory as a stepping stone for future deep space exploration.
Well, certainly we have an opportunity, I think, in the space station program to be able to show something that's real, that's on orbit, it's something that's there today.
It's built for science, it's ready to go, and so now we are going to use it to its full extent. So we want to bring on new researchers, bring on new educational opportunities, bring on new commercial opportunities, and make this thing fully usable so that we bring good results back to Earth.
Through our investment in space technology and R&D, and our partnerships with private industries, and our constant efforts to out-innovate the world, our scientists are innovating new chapters in space exploration.
And you are go to arm toe separation.
We're exploring new destinations, identifying and studying asteroids, all on our pathway to Mars.
We're getting bolder, so we need to make sure that the science is behind all those big, lofty missions.
Can we really, truly jump on an asteroid and then redirect it out of Earth's path so that it doesn't hit Earth and we don't have catastrophe and things of that nature? I mean, what better benefit to mankind?
And to do that, we need to test and develop next-generation technologies. Through advanced aerospace technologies used in everything from modern aircraft to suborbital rockets and the commercial vehicles servicing low Earth orbit today, we're building the machines to take us farther into the high frontier.
When you say think out of the box, well, looking at other planets is thinking out of our planetary box, the Earth.
We're using these technologies to answer some of the critical questions facing Earth right now and in the future. We need to know more about climate change, natural events, and the forces that affect us every single day.
This mission will provide the best global data set of precipitation that we've ever had. And that's really important for everybody from understanding drought in the Southwest to the monsoon patterns in Asia.
These are big questions about our Earth and about our climate, and if we want to be able to make sure the Earth is still a healthy place for people to live in 50 years, we need to understand these things, so it's important from that sense.
We want to understand global processes, and that's why we use satellite images, because we have a large view of our Earth, areas that are very, very remote that we can't get to very easily, and we can observe these areas continuously.
Exploring the universe is what we do. We're committed to answering those fundamental questions about the cosmos, its origins and how it works, and if there's life out there somewhere.
I think some of the most amazing things that we're learning are actually how to be really good detectives on another planet, which is a really difficult job.
Europa is one of the few places in the solar system where we know liquid water exists. It exists underneath this ice shell. There's an exciting possibility that there might be life underneath that ice shell.
NASA is here to raise the bar for human achievement.
I like to think that exploration is encompassing and inclusive. It encourages everybody to expand and reach, and in doing that, more people realize that they can expand and reach.
I don't even know if the scientists who developed the technology and had the vision to create JWST understand what we're going to get as far as the data. It's probably going to be spectacular.
MMS is actually studying the very trigger of space weather, which is where magnetic field lines come together. Hundreds of years ago, we may not have cared so much that space weather was happening all around us, or these phenomena with the solar wind were happening, but we do today.
NASA is everywhere, on every airplane. We're with you when you fly. Constantly monitoring the health of our home planet. Earth is changing and we're on it. Permanently working and living in space, reaping benefits for all of us here on Earth. Speeding across the solar system in search of new discoveries. Breaking the boundaries of interstellar space. Looking into our past with NASA's great observatories. Investing and creating those game-changing technologies. And we're doing it all to help secure our future. We're a community dedicated to research and discovery in service to society. We have a responsibility to the future generations, to the future generations of engineers, scientists, technologists, explorers. That's our challenge.
And part of that mission begins here today with the launch of the SpaceX Falcon 9 rocket, delivering Dragon to the International Space Station. We're at T-minus 42 minutes, 45 seconds and counting. And earlier this week, on Monday, NASA signed a property agreement with SpaceX for use of the Kennedy Space Center Launch Complex 39A, the site from which numerous Apollo and Space Shuttle missions began.
With me today are our administrator, Charlie Bolden.
We are here today to announce an agreement that we just signed with SpaceX for use of this historic launch pad 39A. NASA has today's property agreement with SpaceX that allows them to develop Launch Complex 39A to serve as a platform to support the company's future commercial launch activities.
Under this 20-year agreement, SpaceX will operate and maintain the facility at its own expense. NASA Administrator Charlie Bolden also pointed out that about a mile away from Launch Pad 39A lies Pad 39B, which you can see here. And from 39B, NASA is preparing for our deep space missions to an asteroid and eventually to Mars. The parallel pads at Kennedy perfectly exemplify the NASA parallel path strategy we were talking about for human spaceflight exploration. U.S. commercial companies providing access to low Earth orbit and NASA deep exploration missions at the same time. The reuse of Pad 39A is part of NASA's work to transform the Kennedy Space Center into a 21st century launch complex that's capable of supporting both government and commercial users. At the same time, NASA and Lockheed Martin are assembling the agency's first Orion spacecraft in the Operations and Checkout building while preparing Kennedy's infrastructure for the Space Launch System rocket, which will lift off from Launch Complex 39B. Pad A was first used to launch Apollo 4 on November 9, 1967. It's the site where Apollo 11 lifted off for the first manned moon mission in 1969, and the pad most recently used for Space Shuttle Atlantis' launch to the International Space Station July 11, 2011 on STS-135, the final shuttle. This agreement with SpaceX ensures that Launch Pad 39A will be used for the purpose it was built, launching spacecraft. And here we're looking at Space Launch Complex 40, very close in proximity to the Kennedy Space Center launch pads. Falcon is preparing to launch. T0 time again is 3:25 and 22 seconds p.m. Eastern Time. We're about 40 minutes away from launch. This is Falcon Launch Control. This is Falcon Launch Control at T-minus 39 minutes and counting. SpaceX 3 is launching to the International Space Station, which has been permanently occupied for more than 13 years, and currently the 39th expedition is aboard, awaiting the arrival on Sunday of Dragon. The crew consists of Koichi Wakata. He's the commander of the mission from the Japan Aerospace Exploration Agency. Also aboard are flight engineers Oleg Artemayev from Roscosmos, Steve Swanson from NASA, Alexander Skurvatskov of Russia, and Rick Mastracchio from NASA. The last crew member, Mikhail Turin from Roscosmos, is aboard. This crew of 6 is working on a lot of different projects: high-definition camera equipment, growing plants in space, and a variety of physical science, biology, and biotechnology experiments are defining the research that Expedition 39 is conducting. Other investigations include human research, technology demonstrations, and educational activities. The Expedition 39 activities will continue to advance our body of scientific knowledge, provide a platform for Earth and astronomical observation, educate and inspire younger generations, and prepare future crews for deep space exploration beyond low Earth orbit. The Expedition 39 crew will be active next Wednesday, conducting a spacewalk. NASA astronauts Rick Mastracchio and Steve Swanson are scheduled to conduct the spacewalk Wednesday, April 23rd, to replace a backup multiplexer demultiplexer, or MDM, that failed during routine testing on April 11th. The box is one of the station's 2 external MDMs that provide commands to some of the space station systems, including the external cooling system, solar alpha rotary joints, and the mobile transporter rail car. NASA TV coverage of the April 23rd spacewalk will begin at 8:30 a.m. Eastern, and the spacewalk is scheduled to start at 9:20 a.m. If, for some reason, today's SpaceX launch is postponed, the 2 Expedition 39 astronauts would conduct the spacewalk on Easter Sunday. NASA TV coverage would begin at 8 a.m., and the spacewalk would begin at 8:55 a.m. At this point, though, there is nothing standing in the way of a successful launch of the Falcon 9 rocket. We are 36 minutes, 23 seconds away from liftoff. This is Falcon Launch Control. This is Falcon launch control at T-minus 34 minutes, 35 seconds and counting. The team at the SpaceX Launch Control Center here in Cape Canaveral, Florida, is working no technical issues at this time. Weather remains go. There are no constraints preventing launch at this time. The forecast still calls for 60% favorable weather during the time until launch. Again, that's 3:25 p.m. Eastern Time. Today's launch will consist of about 1,100 kilograms of research supplies to support the 150 investigations, both new and ongoing, that are being conducted during the course of both expeditions 39 and 40. The investigations are focused on the areas of human research, biology and biotechnology, earth and space science, physical science, technology development, and education. And one of the investigations is Opals, which is a new technology demonstration designed to lay the foundation to send data back to Earth from the International Space Station at much faster rates than currently is being done today. Opals stands for the Optical Payload for Lasercom Science, and it was developed by NASA's Jet Propulsion Laboratory. It will be NASA's first payload to demonstrate optical comm data transfer from the space station. Optical comm is an emerging technology that modulates data onto laser beams, and the laser beams have the potential of carrying much higher data rates than achievable with radio frequency or RF transmissions. It's very important because for scientific instruments, they are increasingly requiring support for high data rate applications like high-definition video streams. Once Opals is delivered, it will be located externally on the space station, and as it orbits the Earth, it'll make contact with a ground-based receiving telescope at Table Mountain near JPL, where a typical data transfer, such as video, will take place over a period of about 2 minutes, while the receiver and Opals are within line of sight of each other. And what you see here are images of the Opals hardware as it was being prepared to pack for launch. Currently, many of our deep space missions communicate at 200 to 400 kilobits per second, and Opals will demonstrate up to 50 megabits per second. This is JPL's first external ISS payload and the first SpaceX launch. SpaceX 3 also is launching the Vegetable Production System, or VEGI, to the space station. VEGI is a plant growth system that will provide the necessary lighting and nutrient delivery for plant growth in space, supporting a wide range of uses, from research to education to a fresh food source for astronauts. The VEGI system will be the simplest plant growth system on the space station to date, but will provide the largest surface area yet to grow plants. The first that will be grown is lettuce, as you see here, which will be harvested and returned to Earth for nutrient and microbial analysis to determine the fitness for eating. The system can be deployed and stowed as needed on the space station and can run on less power than a desktop computer. The plants are grown in individual pillows that act as little pods of nutrients and root matting for each plant. In addition to plant growth for producing edible crops, scientists are also exploring the future research that looks at behavioral impacts of plant growth in space, in addition to educational outreach opportunities. Another investigation is the T-cell activation and aging investigation, which is funded by the National Institute of Aging. This study will use microgravity as a novel and accelerated model system of aging to investigate the mechanisms of immune suppression that are commonly seen in the elderly, as well as to understand why the immune system of astronauts is suppressed in space. Human immune systems protect us from disease, and the T cells are the first cells in the immune system that are mobilized when an illness is detected. In a healthy immune system, the T cells in turn call on other critical cells that mount an immune defense against the invader. These investigators' previous spaceflight studies have shown that gravity affects early activation of T cells in ways that were strikingly similar to the depressed immune systems of elderly populations. The study launching today will send up human T cells that will then be activated with a simulated infection that's allowed to proceed on orbit before returning home for a sample analysis. Ultimately, the findings could be beneficial in new treatment strategies for immune system dysfunction. These investigations are just a sample of the science that's enabled by the SpaceX 3 launch and that contribute to the advancement of the human exploration of space as well as our daily lives here on Earth. So very important experiments going up, and this is just a small sample. We're just under T-minus 30 minutes and counting. This is SpaceX Falcon Launch Control.
CE, execute the terminal count poll. And work. Copy that. LC, perform final launch preparations.
That's in work.
Copy that, proceeding.
SpaceX Launch Director Ricky Lim asking Launch Conductor Brian Childers to prepare for the final sequence here of launch for Falcon 9 and Dragon today. We're 28 minutes and 15 seconds away from launch. Looking at a live shot now from the International Space Station Mission Control Center in Houston. Previously, we looked into the Space Station Mission Control Center in Hawthorne, California. Both control centers are prepared to follow the flight of the Falcon 9 once it lifts off today from Cape Canaveral Air Force Station. Here at Cape Canaveral Air Force Station in Florida, we're looking at the SpaceX Launch Control Center, where teams are monitoring the systems of both the Falcon 9 rocket and the Dragon capsule. Currently, we are not working any major technical issues, and weather continues to be green. 26 minutes and 38 seconds away from launch. This is Falcon Launch Control.
CELC on the countdown net.
CE.
Can you set the warning phase to terminal count?
Certainly.
This is Falcon Launch Control at T-minus 25 minutes and 12 seconds. With today's launch, NASA will carry 5 small research satellites, or CubeSats, on the Falcon and Dragon for 3 universities and NASA's Ames Research Center at Moffett Field, California. This is part of the 5th installment of the Educational Launch of Nanosatellite, or ELANA mission. Over 120 students have been involved in the design, development, and construction of the CubeSats that will be flown on this SpaceX 3 mission. The CubeSat launch initiative enables the launch of the CubeSat projects designed, built, and operated by students, teachers, and faculty to obtain hands-on flight hardware development experience. This Ilana 5 mission with its 5 CubeSat projects is managed by NASA's Launch Services Program at the Kennedy Space Center in Florida. There will be 4 P-pods aboard the Falcon 9 rocket that will ferry them into space. After the main payload is deployed, the CubeSats will separate from their P-pods. After 45 minutes in orbit, the CubeSat transmitters will turn on, and university ground stations will listen for their beacons, determine their small satellites' functionality, and announce operational status. CubeSat mission durations and orbital life vary, but are anticipated to last at least 90 days. Upon mission completion, the CubeSats fall to Earth, burning up in the atmosphere.
Well, each team has their own ground station set up, and some of them...
OSM, LC on the countdown net?
OSM.
Yeah, OSM, just a reminder, the plus count after T plus 0, please move over to pad net A.
Roger.
This is Falcon launch control at T-minus 21 minutes, 28 seconds, and counting. The SpaceX Launch Control Center team not working any technical issues, and weather is cooperating. Mother Nature is providing a window of opportunity today for the launch of the SpaceX 3 mission to the International Space Station. And as we continue through the count, the next major milestone will be the terminal countdown, which begins at T-minus 10 minutes, at which point all systems are autonomous. At T-minus 2 minutes 30 seconds after polling Mission Control in Houston, Texas, and the launch team at SpaceX Mission Control in Hawthorne, California, Launch Director Ricky Lim will give a final go for launch. At T-minus 2 minutes, the Air Force Range Safety Officer will confirm the physical safety of the launch area and the eastern range, and 1 minute before launch, the flight computer will be activated. 55 seconds before liftoff, the launch pad's water deluge system, which is dubbed Niagara, will be activated, which suppresses the acoustic waves that radiate from the engine plumes at the time of liftoff. This counters the effect of the vibration on the rocket. There are 53 water nozzles set low on the launch pad that provide a curtain of water flowing at 30,000 gallons per minute. 3 seconds before launch, the 9 Merlin engines of the first stage are commanded to ignite.
T-minus 20 minutes.
And at T0, the rocket computer commands the launch mount to release the Falcon 9, and the rocket will lift off, putting out 855,000 pounds of thrust. We're at T-minus 19 minutes, 36 seconds and counting. All continues to go well. This is Falcon Launch Control. T-minus 18 minutes and counting. T-minus 16 minutes and counting.
T-minus 15 minutes. All personnel stand by for their final poll at T-minus 13 minutes.
This is Falcon Launch Control. All continues to go well. Standing by for the final poll. Once Falcon lifts off at 3:25 p.m., The first stage engine will burn for about 2 minutes and 41 seconds, followed by staging, and the second engine will start at 2 minutes 45 seconds into flight. About 3 minutes and 52 seconds after liftoff, the Dragon nose cone will be jettisoned after the spacecraft successfully goes through the heavy portion of the atmosphere. The second stage engine cutoff, or SECO, will occur at 9 minutes and 43 seconds after launch, and Dragon will separate from the second stage 10 minutes 15 seconds after liftoff. That'll be followed about 7 seconds later by the deployment of the picosats, and the solar array deployment 12 minutes after liftoff. Weather continues to be green. There are no constraints and no major technical issues being worked. T-minus 13 minutes, 45 seconds and counting.
This is Falcon Winds.
We had termination of HR6 at 55.5 K feet, and it had 9 edits.
Copy that, thanks.
Cape Winds out.
Okay, T-minus 13 minutes. All stations verify ready for launch. FTS.
FTS go.
Prop.
Prop go.
AVI.
AVI go.
GNC.
GNC go.
Ground.
Ground go.
VC.
VC go.
GC.
GC go.
RC.
RC go.
DC.
DC go.
OSM.
OSM go.
ROC.
Go.
CE.
Go.
MD.
MD go.
LD.
LD go.
LD verify go to initiate terminal count.
LD go for initiate terminal count.
SpaceX Launch Director Ricky Lim completing his poll. All stations go.
T-minus 12 minutes. VC and DC start the terminal count auto sequences set to start at T-minus 10 minutes.
Copy that, proceeding. Copy that.
If a hold is called from this point forward, the terminal count auto sequence will be aborted. Indicate an abort or hold condition by saying hold, hold, hold on the primary countdown net. In this event, the VC will immediately abort the auto sequence. The VC shall not abort the auto sequence after T-minus 10 seconds, and operators shall not call a hold after T-minus 10 seconds. If a hold is called, all operators proceed to the terminal count abort steps in section 10.62. Attention all to pick up the count, T-minus 10 minutes and counting. On my mark.
We have on-time release of HR8.
Copy that, thanks.
3, 2, 1, mark. BC announce auto sequence has started.
Terminal count has started.
GCVC standby on FireX.
Standing by. Standing
RC
by.
start the camera video recorders.
Roger.
OSM set launch enable to flight.
Flight.
First stage engines are chilling in. Ground T-tip system setting up.
Engines are chilling in.
Ground helium spin start system is set up.
T-minus 9 minutes.
All systems remain go. Weather remains green. Everything set for a launch today at 3:25 p.m. and 22 seconds Eastern Time of Falcon 9 and Dragon.
Falcon Winds, this is Cape Winds on the Weather Brief Net.
This is Falcon Winds.
We missed the first 1,400 feet.
T-minus 8 minutes.
Data on HR8. Is that a problem? Do we need to
Nitrogen ACS closeout has started.
We do. That was our last balloon.
Copy. Then yes, we need to re-release.
Okay. Cape Winds out.
Heater end, stage 1 has started.
T-minus 7 minutes.
The Falcon 9 rocket poised at Space Launch Complex 40 at Cape Canaveral Air Force Station in Florida, venting oxygen. You can see the plume coming off of the rocket. All systems remain go.
Heater end, stage 2 has started. Internal stage 1 and stage 2 have started. Ground TVC tank is pressing.
T-minus 6 minutes.
First and second stage tanks are pressing in preparation for strong back retract.
The strong back about to be retracted away from the Falcon 9 rocket.
Stages on both tanks are at pressure. Crown TVC tank pressed to 1300 psi.
T-minus 5 minutes.
Strong back is retracting.
T-minus 4 minutes, 30 seconds and counting. The strong back is retracting away from the Falcon 9 rocket in preparation for launch.
T-minus 4 minutes.
GNC confirms good stage 2 TVC motion. And we've reached 77.7 degrees. Pinning strong back in retracted position.
FTS is on internal power.
The flight termination system is on internal power.
FTS is armed.
T-minus 3 minutes.
Standing by for a final go-no-go poll for launch. T-minus 2 minutes, 43 seconds and counting.
LD, verify go for launch.
LD, go for launch.
Vehicles in self-alignment. First stage tanks pressing.
Rock, verify range go.
Range green.
Everything is go. The eastern range is green. Weather is go. No technical issues. 1 minute, 50 seconds away from launch.
Vehicles back in manual mode.
One minute before launch, the flight computer will be activated to begin final pre-launch checks. 1 minute, 10 seconds.
Vehicles in auto idle. Vehicles in startup. The flight computer has control of the vehicle.
Dragon. Confirm Dragon is in startup. DC countdown at, confirm you're in startup.
DC confirms flight computer is in startup. Second stage pressing. Tanks are at flight pressure.
Oxygen and RP-1
Engines
tanks
are chilled for flight.
pressurized for
30
flight.
seconds.
Everything is go.
T-minus 20.
The engine controller will
15.
command the engine ignition sequence to start at T-minus 3 seconds.
T-minus 10, 9, 8, 7, 6,
5, 4, 3, 2, 1. And liftoff of the Falcon 9 rocket and Dragon. SpaceX 3 is underway. An American commercial spacecraft launching from U.S. soil makes a special delivery of new science and technology to the International Space Station.
First stage propulsion is nominal.
mission.
Status, power system not on.
At 1 minute and 13 seconds after liftoff, Falcon 9 will reach supersonic speed. Falcon 9.
First stage propulsion is nominal.
Power system nominal. Solid telemetry lock on both stages.
Falcon 9 passing through the area of maximum dynamic pressure. 1 minute, 45 seconds after liftoff.
T plus 110 seconds, altitude 24 kilometers, speed 785 meters per second, downrange distance 30
MVAC
kilometers.
is chilling in.
Vehicles flying down the nominal.
Main engine cutoff expected at 2 minutes 41 seconds. 2 minutes 15 seconds into flight now.
T plus 2 minutes 30 seconds. Vehicle vehicle 63 kilometers altitude, speed 1.8 kilometers per second, downrange distance 55 kilometers.
Stage separation confirmed.
And we have MECO 1.
Main engine cutoff and separation of the first stage have occurred.
And MVAC ignition.
T plus 3 minutes. Vehicle altitude 103 kilometers, speed 2 kilometers per second, downrange distance 103 kilometers.
The second stage engine has ignited to begin about a 7-minute burn that will bring Dragon into low Earth orbit. Three minutes, 30 seconds into flight.
Stage 2 propulsion is nominal.
Falcon power systems nominal. Solid telemetry lock on both stages.
T plus 4 minutes 45 seconds. Vehicle altitude 205 kilometers, speed 2.4 kilometers per second, downrange distance 285 kilometers.
Everything going well as Falcon 9 and Dragon make their way toward the
Vehicle
International
continues
Space
to fly
Station.
down the nominal trajectory.
Five minutes, 30 seconds into flight.
Stage 2 propulsion is nominal.
Falcon power systems nominal. Solid telemetry lock on both stages.
Six minutes, 12 seconds into flight. The crew aboard the International Space Station watching launch of Falcon today as the rocket and Dragon capsule make their way toward an Easter Sunday morning delivery.
T plus 6 minutes 40 seconds. Trajectory status 284 kilometers altitude. Speed 3.6 kilometers per second. Downrange distance 600 kilometers.
Stage 2 propulsion still nominal.
Seven minutes, 21 seconds into the flight of Falcon. About 2 minutes away from second stage engine cutoff.
Stage 2 propulsion is nominal.
T plus 8 minutes 15 seconds. Altitude 322 kilometers. Speed 5.3 kilometers per second. Downrange distance 980 kilometers. Still getting excellent video of the first stage, having performed its entry burn, and excellent video from the Air Force New Hampshire tracking station on the second stage. Vehicle continues to fly down the nominal.
Terminal guidance has begun.
T plus 9 minutes, 15 seconds.
And we're in terminal guidance. Stand by for engine cutoff.
FTS is safed. And we have SECO 1.
Falcon 9 second stage engine cutoff on time. SpaceX 3 is in orbit.
Dragon deploy confirmed.
And Dragon has been deployed successfully from the Falcon 9 rocket. Ten minutes, 35 seconds after launch. Dragon flies through the blackness of space on its way to a meeting with the International Space Station Expedition 39 crew on Sunday morning. T plus 11 minutes, 29 seconds. At SpaceX headquarters in Hawthorne, California, the crowd has gathered in the Mission Control Center and outside to watch the Dragon on its way after a successful launch by the Falcon 9 rocket. And the solar arrays are being deployed, generating power to the Dragon spacecraft as it makes its trek to the space station. This is Falcon Launch Control at T plus 13 minutes, 56 seconds. After a successful launch of the Falcon 9 rocket today, within the next several minutes, PhoneSat, KickSat, and SporeSat will be deployed. And over the next several days, the next couple of days, Dragon will make its way through a carefully choreographed sequence of thruster firings to reach the International Space Station. This concludes our launch coverage of the launch of Falcon 9 and Dragon. Dragon is set to arrive at the station on Easter Sunday, April 20th, and NASA television will begin coverage at 5:45 a.m. Eastern Daylight Time for an expected grapple at 7:14 a.m. You can follow the SpaceX 3 mission activities on Twitter using @NASA and @SpaceX, and by using the hashtag ISS. And of course, you can follow us on the web at www.nasa.gov/SpaceX. The next event on NASA television will be a post-launch news conference at approximately 5 p.m. Eastern Time. Once again, you can keep track of the mission at www.nasa.gov/SpaceX. Thank you for joining us. We will leave you with a replay of the launch of Falcon 9. This is Falcon Launch Control.
Tanks are at flight pressure.
T-minus 20.
The engine controller will command the engine ignition sequence to start at T-minus 3 seconds.
T-minus 10, 9, 8, 7, 6,
5, 4, 3, 2, 1. And liftoff of the Falcon 9 rocket and Dragon. SpaceX 3 is underway. An American commercial spacecraft launching from U.S. soil makes a special delivery of new science and technology to the International Space Station.
First stage propulsion is nominal.
The engine controller will command the engine ignition sequence to start at T-minus 3 seconds.
T-minus 10, 9, 8, 7, 6,
5, 4, 3, 2, 1. And liftoff of the Falcon 9 rocket and Dragon. SpaceX 3 is underway. An American commercial spacecraft launching from U.S. soil makes a special delivery of new science and technology to the International Space Station.
First stage propulsion is nominal.
Seconds into flight.